In this video, we're going to look at second order linear homogeneous equations. Same thing we've been doing, but this time when we're at this step and we solve for r, we're going to have an imaginary component to our r values. So then we're going to use, when we write our general solution, we're going to have an imaginary component. So then we're going to use Euler's formula to rewrite our general solution so that we get rid of the imaginary numbers. So, like for example, in this case, we're going to have an R1. We can take the positive value for R1 and a negative value for R2. I'm just extending off of what you should already know before you come into this. You should already be familiar with second order ODEs. So now we have R1, R2. We write our general solution would be C1 e to the a plus ib. Now this is just hypothetical, right? Our a and b they're just real numbers basically. They could both be 1, right? And I'm going to show that in 1 minute. Oh, sorry, this should be times t, right? Not I. Okay, so now let's just assume that a and b are equal to 1. So then we can rewrite this as c1 e to the 1 plus I times t plus c2 e to the 1, what's that? Oh, this should be minus, right? So now you can see we have imaginary numbers left. So first things first, what you should always do in this situation is you should never leave it like this. You should always rewrite it so that you separate these two terms. Right? Do you see how I did that? You should always rewrite it like this, because Euler's formula is only going to apply to the second half of this, the imaginary half of these equations here. The imaginary half. Euler's formula only applies to this second imaginary half here. So, Euler's formula goes, let me write this as Euler's formula is e to the it equal to cosine of t plus I sine of t, and that's Euler's formula. Now this, I'm not going to derive the formula, but I will later on when it becomes necessary in systems of ordinary differential equations. Now, not all schools cover systems. Sometimes it's optional section. Professors won't always cover it, but my professor did, and it was my favorite section ever. So all of this, especially the second order stuff, is going to come back so much in systems, and it's going to be basically required that you understand where Euler's formula comes from. It's not necessary until later on. So for now, you might not even need systems, but I'm going to do videos on them later on, and they come before PDEs. But anyways, in this, we're not there yet. In this, we're just going to look at Euler's formula. For now, just memorize the formula. Don't worry about where it comes from. If you need to, we can worry about it later, is what I'm trying to say. So now, let's see. What was I doing? Okay, yeah, so now we just plug in. You see we have these imaginary things. They apply to this. So y is equal to c1 e to the t this is easy, right? E to the it is Euler's formula, right? So that's just cosine of t plus I sine of t. And the second half is just c2. Actually, I should, instead of writing it out as a general solution first, I should break it up like this. y1 is this. Because technically I haven't written the general solution yet. I shouldn't write it like that yet. Right, it's still y1 and y2. So I'm gonna get rid of these c1s then. Yeah, definitely. Okay, so then we have y1 and then our y2 is e to the t. Now this time we have negative it. Now whenever we have a coefficient up there, doesn't matter if it's negative, positive, whatever, it's going to apply to the t. So for example, this would be cosine of negative t. And this would be sine of negative t. Now this can be rewritten, right? Remember, if you think about back to trig or pre-calc, whatever, cosine is an even function. So this can be rewritten as cosine of t. And this can be rewritten, the negative will come out, this is minus I sine of t. Right? So if we add, so now we have to add y1 and y2 together. So now we're going to add, sorry, this is our original y1 and y2. This is our y tweedle and y2 tweedle. They're our new y1 and y2. We shouldn't call it the same thing. So now if we add y1 tweedle and y2 tweedle together, we'll be left with right. So we'll have e to the t. We'll have 2 e to the t cosine of t's, right? So I'm going to do a little bit in my head here. You're going to find out very shortly that differential equations really just becomes algebra. Differential equations is the easy part. It's the algebra that really starts to get you. You'll see what I mean in the next few sections, especially undetermined coefficients. Those problems are evil sometimes with the algebra. Alright, anyways, where was I? I think that might be it. I believe those signs are going to cancel, I think. By the looks of it, that's exactly what's going to happen, I think. Okay, so now we have y1 plus y2, but now what if we change the sign on just one of them? It doesn't matter which one, but if we just change the sign, let's say we change the sign on y1, we'll be left with, right? This would become we'll be left with right? Oh, 2i, right. Actually, I just realized something. These up here should be tweedles. Because now we're going to go back to our original y1, which is basically proposing, was proposing e to the rt. So now these basically are going to be our two, solutions. This y1 plus y2, and if you flip the signs. So these are going to be our two y's, basically. Think of it like. So for the first one, sorry, I was just looking at my professor's notes, and I'm a little confused here. I'm confused on why he has these 2's right here cancel. I'm not sure why he does that. But basically what I've gotten from this is, I guess you can kind of, let's get rid of this step here. I think I know a better way of explaining this. So basically we can just look at one of them. Let's just look at y1. If we start with y1, we're gonna have I'll call this like a u and a v. So like we're gonna have u would be e to the t cosine of t, and v would be, I'm not sure what happens to this I here. It seems to just disappear. Well, so you're going to look at this section and this section, and the I for the V disappears. I'm not entirely sure why. Give me 1 second. Let me try and figure it out. All right, so I'm not too sure, but the reason why I'm not too confident with this stuff is because I've never actually looked at the derivation behind this. There's a much easier way to go about doing these solutions, and I'm gonna do it in 1 second. Just this was the long way, and I'm honestly getting confused now because I've never done it this way before. But anyway, if we look at this u and v, then we're gonna have our general solution is gonna be like a c1 times u plus a c2 times. Now, I would assume that maybe some professors will go through this whole derivation like mine did, and I honestly don't remember it, so that's why I'm confused. Because I always looked at these a different way. So now I'm going to show you how I do them with some examples here. Let's look at some examples. So this first one, I just wants us to find the general solution of the differential equation. We don't have any IVPs yet. We will later though. So for this first one we have, so first step is to propose, right, just like before. So then this is y double prime. Okay, plug those in, we're left with, I'm going to do some canceling in my head. We should be at that point by now, right? We can just do that in your head. Cancel out the e to the RT's. Now, you're going to notice that this is not going to factor nicely. We have to use quadratic formula. So I forgot. Step 2, substitute. Step 3, solve for r. So basically, oh yeah, like I said before, we have to use the quadratic formula. So for this one, r is equal to, remember it's negative b, so negative b in this case would be 2, plus or minus the square root of negative 2 of b squared, which is negative 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 2, over a times, over 2 times a, which is 2 times 1. This is equal to r, 2 plus or minus the square root of, that would be 4 minus 8, negative 4. Now, just recall, that the square root of -1 is equal to I. So that tells us that I squared is equal to -1, basically. Sorry, this is kind of hard to read. Okay, so knowing this information, we can rewrite R to be, right? So then this leaves us with 2 plus or minus 2I over 2. If we take the positive one, we're going to have 2 plus 2I over 2. If we take the negative, this would become 1 plus I. If we take the negative one, we'll have this, which is just 1 minus I. Right? So that tells us that our y1 is going to be e to the 1 plus I times t, and our y2 would be now I would rewrite this to be e to the t times e to the it. Y2 would be and I was kind of going back into the formula there. Let me actually erase this, forget about this. Let's not do it the long way. And let's just look at it like this. Okay, so think of it like this. So now we're going to do our general solution. So whenever we write our general solution when we have a complex, it's going to look like this. We're going to we're always going to propose an e to the t, okay? So it's going to focus on this first real number here. For this one at least. We're going to focus on this first one only. So it's going to look like this. We're always going to have a c1 e to the t. And we're always going to have a c2 e to the t. Because this is basically like saying we have this 1 is going to carry down to here. And then in the background, Eulers Formula was applied. But we can just skip all of that and go right to this. For every single one of these problems, we're always going to have a cosine term and we're always going to have a sine term. It doesn't matter which one goes where, but typically write cosine first and write sine is in the second one. It's always going to be this way every single time. And don't forget that that 1 is actually carried down to here. Okay? So now I believe I have 3 other quick problems that are like this. So let's just go through these quickly. Okay. So in my head, I'm going to propose e to the rt. So when I do that, I know that this is going to be r squared, right? You can go ahead and do it on your own, but I'm going to skip all of that because we should know how to just go right to here by now. Once again, you cannot factor this out. So r is equal to, this would be negative b, so negative 2 plus or minus 4 square root of 2, right? 2 squared. Minus 4 times a times c over 2 times a. This is negative 2 plus or minus the square root of 4 minus 8. Looks like the same thing almost as the last one. Just we have a different sign out front. So for this one, we're going to have negative 2 plus or minus 2i over 2, right? So our R1 would be negative 1 plus I. R2 would be negative 1 minus I. So right to here, I can skip writing down y1 and y2, even though I should, and I can just go right to the general solution, right? I can go right to the general solution. We're just going to combine y1 and y2 and use Euler's formula. So now remember, we're going to have c1 e to the negative t, right? Because of this negative 1 here. That negative 1 is going to carry to here. Times, this would just be sine of t, and then plus c2 e to the negative t cosine of t. Oh, I just remembered. I remembered how this formula works. I have misled you on this last one. This 1 does not carry to here. What actually carries into this t is the coefficient on the I term. Now the negative and positive is irrelevant in this case for this formula. It's just the number value, the absolute value of the number that's out front. So in this case, it would actually be 1 and 1, but it's from the second term, the one that's outside of this. Plus and minus doesn't matter. That's where the sign comes from. Remember how we did it with the long way? Okay, anyways, now that we got that out of the way, you can see here that once again we still have a 1 here and a 1 here. So that's going to translate down to here. So that's why those are just sine of t and cosine of t. And this is our answer for this one. So now for the next one, number 9, try this one on your own. Yes, we have a decimal here. Not so nice. So try this one on your own and see if you can get the answer. The answer is actually really nice, by the way. Just it looks bad, but trust me, don't be afraid of decimals. Typically textbooks make it nice so that the numbers work out nicely. So go ahead, try it on your own, and I'm going to do it right now. So pause the video, try it, and I'll do it right now. So plug in, first of all, 1.25 is equal to 5 over 4, right? So then we have r squared plus 2r plus 5 over 4 equals 0. Right, I proposed y equals e to the rt, plug them in, cancel the e to the rt's, we're left with this. And so now, solve for r, quadratic formula. Y is equal to negative 2 plus or minus square root of 2, 4, minus 4 times a times c. See how this works out nicely? See, you can see those 4s are going to cancel. Over 2 times a. This becomes negative 2 plus or minus square root. This becomes 4 minus 5, right? Because those 4s will cancel and we're just left with minus 5. So then r is negative 2 plus or minus I over 2, right? Because this is just negative 1. And we know that this is just that. Okay, so now we have r1 would be negative 2 plus I over 2, which can be rewritten as negative 1 plus or minus 1/2 I. Now you can see we're going to have a coefficient in front of the I. So now it's going to matter what's in our sine and cosine terms. So r2 would be negative 1 minus 1/2. I'm sorry. right? R1 is plus, R1 is the minus term. We can now write our general solution where y is equal to, it's always C1e. Now, for this first one, we look at the first one, negative t. For this, we look at this. Okay? Same thing goes for the second one. First term is negative 1, so this negative carries up here. For the second term, remember, we disregard the negative and positives when this should be signed. We don't worry about the negatives or positive. That's just 1/2. You just look at the absolute value of the coefficient. Okay, that's the answer to this problem. See, so far not too bad. If you learn it this shortcut way, these problems are pretty quick, right? So now, let's go down. I believe we have one more like this. Yep, one more. 6.25. Well, 6.25 is equal to, what is that? Let me think about this. 25 over 4, right? So now, this would become r squared plus 4r plus 25 over 4. And I can already see that those 4's are going to cancel in our quadratic equation. See, once you do this for a while, you can kind of foresee what's going to happen. So this is equal to what? B squared, so I'm sorry, negative b squared. See what I mean? Those 4's are going to cancel over 2 times 1, which is just 2. This becomes negative 4 plus or minus, that's 16 minus 25 over 2. This would be negative 2 plus or minus the square root of, what was that, negative 9? So then that tells us that R1 would be negative 2 plus 3i over 2. I'll simplify that in a second. Right? R1 would be negative 1 plus 3 over 2i. R2 is equal to negative 1 minus 3 over 2i. Oh, wait a minute. I thought that wasn't right. That should be a 4, right? My bad. That was my mistake. If you caught that, that's good. So then this would become 2, not 1, which is a good thing, because this will give us a case where we have non-1s for both our terms. So general solution, we have y is equal to negative 2, I'm sorry, C1 e to the negative 2t. That comes from the first one. And then for the inside of the cosine, remember, start with cosine. It doesn't matter which one you start with first. Either cosine or sine, whatever. You're going to look at what's in front of the I. And then for the second term, for y2, that stays the same. And so does this. Right? This is our answer. So these are pretty straightforward, pretty simple. Now I believe we have one down here. Yes, I just want to look at 13, I think. Yep, just 13. So these ones are a little bit longer. We have initial conditions. So guess what? We're going to find the general solution. We're not going to sketch the graph. That requires a calculator. We're not going to do that. So let me rewrite this. Okay. So find the general solution of the initial value problem. So let's propose y equals e to the RT. Substitute. Solve for r. This would be 2 plus or minus 4 minus 4 times, that 4 comes from negative 2 squared, minus 4 times 1 times 5 over 2 times 1, quadratic formula, right, is equal to 2 plus or minus 4 minus 20 over 2. So r is equal to 2 plus or minus negative 16 over 2. That tells us that we have r1 would be 1 plus 4i. R2 would be 1 minus 4i. I believe, let me check. 1 plus or minus 2i. Yep. Oh, 2i. Right. That's what happens when I go too fast, right? Simple mistakes. They always get me. Okay, anyways. Let's write our general solution now. So we're going to have y is equal to c1 e to the t cosine of 2t plus c2 e to the t sine of sorry. I almost did what I said not to do. I was just following. But anyways, so now we have our general solution. Let's look at our first initial condition. First of all, we see we need y prime, right? Well, y prime would be oh boy. This is where the algebra gets a little long. So we have, okay. Looks like we have to do the product rule twice. So let's look at the first term here. We have, when I do the product rule, I do the first times the derivative of the second. I guess most people do the second times the derivative of the first, so then this is just going to stay exactly the same. So then we have to do the first times the derivative of the second. Derivative of cosine is negative sine, so this negative is going to come out. C1 e to the t times sine, 2, that 2 comes out as well. Sine of 2t. Right, because you have to do chain rule, so that 2 will come out. So then we have plus second times the derivative of the first is just c2 e to the t sine of 2t, running out of space, plus c2 e to the t plus 2c2 e to the t cosine of 2t, right? So this is a little long. Yes. Okay, so now we use our two initial conditions. Where was I? Okay, so y, and we have, okay, so we have these two initial conditions. So for the first one, we have 0 is equal to c1 e to the pi over 2 times cosine of just pi plus c2 e to the pi over 2 plus sine of pi. Now, what is cosine of pi and what is sine of pi? Well, you should know from trig, right? Use the unit circle or whatever. If you get allowed to use calculators in your class, feel free. But you should, by this point, especially from Calc 3, know the unit circle by now. So we know that cosine of pi would be -1 and sine of pi is 0. So that tells us here that c1 is equal to 0. Excuse me. So knowing this, okay, I better do this one down here. So basically, we're going to have 2. Now, wherever there's a c1, I'm just going to remove. So we're going to have 2 is equal to c2 e to the pi over 2 sine of pi. Once again, sine of pi is 0 plus 2 c2 e to the pi over 2 cosine of pi. Cosine of pi is -1. We're left with 2 is equal to 2c2, I guess -2c2 e to the pi over 2. This would become -1 is equal to c2 e to the pi over 2. This would be right, which can be rewritten so then where was it? Take our general solution. We plug in for c1 and c2. c1 0. c2 is -e to the negative pi over 2 times e to the t times sine of 2t. Okay. So this is a little bit longer video, but we went through a lot of example problems. Second order is a very small section. We only have 3 more things left. The next section is reduction of order. So reduction of order is where the algebra starts getting a little more intense, and it becomes more of an algebra problem than it does a differential equations problem. And you'll see what I mean in the next video.